Good day. Today we're going to discuss rational inequality. In the previous discussion, we defined rational inequality as an inequality in which it contains rational expressions. Now, before we're going to discuss how we are going to solve rational inequality, first let's recall some of the symbols and terms that are essential in understanding the solving inequalities of rational. First, we have the symbol, this symbol. This means that the value of the left side is greater than the value of the right side. And then we have this symbol, which indicates or which means the value of the left side is less than the value of the right side. And then we have this symbol in which the value of the left side is greater than or equal to the right side. And then we have another symbol, the value of the left side is less than or equal to the value of the right side. Now another, we have this symbol, an arrow pointing to the left and another endpoint, and the endpoint has a hollow dot which has a value which is A. This is actually a number line, okay? A number line in which all the numbers from the left are included in the set except for the number A. So all the values, let's say this is -1. So all the values in the left of -1, so you have -2, -3, -4, and so on, they are included in the set. However, the -1 is not included. I repeat, if A is equal to -1 and we have this symbol, this means that all the values in the left of -1, we have -1.1, -1.2, -1.3, up to infinity, negative infinity. They are included in the set except for the letter A or the number -1. These symbols, okay, this symbol also can be written in an interval notation. So the interval notation of this symbol is this one. You have an open parenthesis, negative infinity to letter A. Now, close parenthesis. If we are going to use parentheses in the interval notation, it means to say that the number within the parentheses are not included in the set. However, the numbers between the numbers inside the parentheses are included. Now, we have another symbol. We have here A, okay, another arrow, okay, array, okay. So we have here all the numbers from the right are included in the set except for the number A. So this would be the boundary, okay. Let's say this is 1. So all the numbers of the right in the right of number 1, they are included in the set. However, 1 is not included. Okay, this symbol can be written in an interval notation. So this would be the interval notation. So from A to positive infinity, however, A is not included in the set. Okay, another symbol, we have this one. So the difference of this symbol to the previous slide, we have array, but the endpoint is not a hollow dot. This is a solid dot. This means that all the numbers to the left of A are included in the set, including the A. So in the previous slide, A is not included. But if we use solid dot, that means A is included in the given interval. Now this symbol can also be written in an interval notation. So as we can see here, we use bracket. That means A is included. Okay. Another symbol, we have array pointing to the left, right, pointing to the right rather, and we use solid dot in the endpoint of the array. So that means that A is included to the set going to the right. So all the numbers greater than A are included in the given set. So this would be the interval notation. So we use a bracket again in the left side of A going to infinity. Another symbol, we have this one. We have a line segment, but in this segment, the endpoints are hollow. Okay, so this means that all the numbers between A and B are included in the set except for numbers A and B. So let's say A is 1 and B is 5. So all the numbers between 1 and 5 are included in the set. However, 1 and 5 are not included. So we have a boundary of A and B, and those boundaries are not included in the set. This symbol can be written in an interval notation. So the interval notation of this symbol is this one. Now take note that this is not a coordinate point. Okay. The symbol of interval notation is somewhat the same to the symbol when we are going to write a coordinate point. However, the meaning of this symbol is different to the meaning of the coordinate point. So if we are going to say set in an interval notation, and then we have this parentheses, that means the A and B are not included in the set. Now, another symbol, we have this one. Okay, as we can see here, again, it is a line segment. However, the endpoints in the line segment, we use solid points or solid dot. Okay, that means that the numbers between A and B are included in the set, including the numbers A and B. Okay, so A and B. So in the given set, A and B are included in the given set of points or set of numbers. Okay, we have another. We have a line segment in which the endpoints are not the same symbol. A here is a solid dot, and B here is a hollow dot. Okay, this means that all the numbers from A to B are included to the set except for number B. So B here is not included in the set. It is a boundary, but B is not included in the set. Now, another symbol, okay, similar to the previous symbol. However, in this case, A is not included. So, because we use hollow dot, okay, because we use the hollow dot in the symbol, then it means to say A is not included. However, because we use solid dot in our point B, B is included in the set. Now, here are the steps in solving rational inequalities. First, move all terms on one side and simplify its form by factoring the non-zero side. Now, we have to take note that when we say simplifying the rational inequality, we have to be sure that the other side of the inequality must be zero. And the inequalities should be in the form of factored form. So we have to factor out the terms in the inequalities, and the other side of the inequality must be 0. Next, we have to find the critical points or the key points by equating the numerator and denominator to 0. So we have to identify the key points or the critical points in our inequalities. Then we have to equate numerator to 0 and denominator to 0. And then we are going to find the roots of the numerator and the denominator. Another, step 3, we have to make a diagram by locating these values on the real number line. So in other words, we are going to plot the critical points or the key points to the number line. And then we pick a test point for every region in the diagram. Now let's have an example. Find the values of x that will satisfy x plus 1 all over x minus 4 greater than 0. Now, the first step is we need to simplify the inequality. However, as we can see here, the left side or the right side of the inequality is already 0. And the numerator and denominator can no longer be rewrite as a factored form, because the term x plus 1 and the term x minus 4 rather, are already in the simplified form. So step 1, we already done. Next, equating the numerator and denominator to 0. Now, we equate the numerator, x plus 1 equals 0, to identify our key points. Now, in this case, what would be the number that be added by 1? The result is 0. So, clearly, it is negative 1. And then, our denominator, x minus 4, the x minus 4 should be equated to 0. So, x minus 4 equals 0. So, what will be the number that is subtracted by 4? The result is 0. That is x equals 4. We use this x equals negative 1 and x equals 4 in we are going to locate the negative 1 and positive 4 to our number line. Okay. Make a diagram. Make a number line diagram. So let's say this is our number line. And then we are going to plot the points, the key points. Okay. So that's the negative 1. And then we have positive 4. Now, in this case, we have 3 regions. The first region is all the numbers to the left of negative 1, and then the numbers in between negative 1 and 4, and all the numbers to the right of 4. So in other case, we have all the numbers greater than 4, all the numbers less than negative 1, and we have the numbers that is greater than negative 1 but less than 4. Now, another question, should we include negative 1 to our inequalities if we are going to test points? Now, we have to consider if we are going to include negative 1 in the inequalities. Now, take note that the inequality symbol here states that the right side should be greater than 0. So in other words, the right side should not be equal to 0. Now, if we are going to substitute negative 1 in the inequality, the right side, or the left side rather, the left side becomes 0. Therefore, we are not going to include negative 1. So in that case, we are going to use hollow dot. Another, should we include 4 in our testing of points. Now, if we are going to substitute 4 in our inequality, okay, if we're going to substitute 4 to the x, the denominator becomes 0. Then, if the denominator becomes 0, that means undefined. So since it's undefined, then we are not going to consider 4 in our test of points. So in that case, we are going to use hollow dot. Now, pick a test of point. Now, we have first region. The first region is all the numbers less than -1. So you are going to pick any number which is less than -1. So all the numbers to the left of -1. So less than -1. So let's say the number is x equals -2. So what we are going to do with this x equals -2? The -2 will be substituted to our given inequalities. And then we are going to test whether if we are going to substitute -2 to the equation, if we are going to substitute -2 to the inequalities, whether the result is true or false. Now let's try. We are going to substitute -2 to the x. Now, so we have -2 plus 1. So -2 plus 1. And then we have -2 minus 4. Now, -2 plus 1 equals -6. And -2 plus 1 equals -1. And -2 minus 4 equals -6. Now, -1 divided by -6 is actually 1/6. And then can we say that 1/6 is greater than 0? Yes, it is true. Okay, therefore, we're going to consider the interval negative infinity to -1. Okay, an open interval. Okay, so we are going to consider this interval. Another, the second region. We are going to pick any number between -1 and +4. Let's say that number is 0. Now, the 0 will be substituted to the variables in our inequality. So we have 0 plus 1 all over 0 minus 4 is greater than 0. So 0 plus 1 equals 1. 0 minus 4 equals -4. So can we say that -1/4 is greater than 0? The answer is false. It's not. -1/4 is less than 0. Therefore, this inequality is false. That's not true. And then we have the third region. Pick any number to the right of 4 or any number greater than 4. Let's say 5. Substitute the 5 to our inequality. Then we have 5 plus 1 all over 5 minus 4 is greater than 0. Now, 5 plus 1 equals 6 and 5 minus 4 equals +1. So we have 6 over 1 greater than 0 and 6 over 1 is actually 6. 6 greater than 0? The answer is yes, it is true. Therefore, we are going to consider the open interval 4 to +infinity. Now, for the last step, we can now identify the values that will satisfy the given inequality. We are just going to pick the intervals in our region that are true. So, the numbers are, we have open interval -8, -1, and open interval 4 to +infinity. And then we are going to use the union. And all the values, okay, all the values of this interval notation are the values of x that will satisfy the inequality x plus 1 all over x minus 4 greater than 0. Let's have another example. Let's say find the values of x that will satisfy the inequality x minus 2 all over x plus 3 less than 2. Okay, so x minus 2 all over x plus 3 is less than 2. Now, first step, we have to simplify the inequality. Now, as we can see here, the given inequality, the right side is not equal to 0. Remember that we can say that the inequality is in the simplified form if first, okay, the numerator and denominator are in factored form and the other side of the inequality is equal to 0. Since the right side of this inequality is not 0, then we are going to make the left side or the right side equal to 0. In this case, we are going to make the right side as 0. Now, to make it the right side as 0, we have to subtract both sides by negative 2. Okay, so in this case, we have to subtract here by negative 2 and the other side be subtracted by negative 2. So this would be the resulting inequality. The x minus 2 all over x plus 3 minus 2 is less than 0. Now, is this already a factored form? No, it's not yet a factored form. We have to, another thing, we could say that it's simplified when we have if we have one line, fraction line. By the way, this fraction line can be called vinculum. Okay. So, since we have, since in this case this is not simplified form because we have two terms. Okay, two terms in the left side, we are going to simplify this one. Now, remember that if we are going to operate fractions, okay, it is better that we have to transform one of the fractions. Okay, we are going to transform the fractions into similar fractions. Okay, now, since 2 is not similar to x minus 2 all over x plus 3, we make it similar. Okay, we just going to multiply 2 by the x plus 3. Since x plus 3 is the LCD between this fraction and 2. So the LCD is x plus 3. Now, we are going to operate. 2 will be distributed to the numerator. So we have this one. So x minus 2 all over x plus 3. So we have negative, we have 2 times x, that is 2x. 2 times 3, we have 6. And since we have now two fraction lines, we are going to make this one a single fraction line. Now remember, in operating or if we are going to add or subtract fractions, similar fractions, we are just going to copy the denominator and then operate the numerator. So in this case, we have x minus 2x, we have negative x. Negative 2 minus positive 6, that becomes negative 8, all over x plus 3 less than 0. So in other words, we have now the simplified version of x minus 2 all over x plus 3 is less than 2. The simplified version of this is negative x minus 8 all over x plus 3 is less than 0. Now, for the second step, we have to equate the numerator, negative x minus 8, to 0. So we have this one, negative x minus 8 equals 0. So what would be the negative number that would be subtracted by 8? The answer is 0. So we have negative 8. Another way of solving this one is something like this one. So we have here, we can also say like this. We have negative, the 8 here, and the negative 8 here would be added by 8. And since we're going to add 8 here, we have to add the right side by 8. So we have negative x minus 8 plus 8 equals 8. And then negative 8 plus 8 is equal to 0. So we have negative x equals 8. Now, since we have negative x in the left side, we have to multiply both sides by negative 1. So negative 1 times negative x is x, and we have 8 times negative 1 equals negative 8. So in other words, the value of x here is negative 8. Now, we have already the value of our x in the numerator. Then we have the denominator, x plus 3. So x plus 3 is equal to 0. And then what would be the number? Okay. What would be the number that would be added by 3? The result is 0. So the answer is negative 3. So we're going to consider negative 8 and negative 3 as our key points. Okay. Now, take note that this inequality can also be written as this one. Okay. Now, we're going to plot the key points in our number line. So we make a number line. Let's say that would be our number line. And that would be for negative 8 and negative 3. Now, should we consider, we have in this case, we have 3 regions. We have all the numbers less than negative 8, all the numbers greater than negative 8 but less than negative 3, and all the numbers greater than negative 3. Okay. Now, should we consider negative 8 here? The answer is no. Because if we substitute negative 8 in the equation, if we're going to substitute negative 8 in the inequality, the numerator becomes 0. And since in this inequality, it should be less than 0, it is not greater than or equal to 0, then we are not going to consider negative 8. Now, should we consider negative 3? The answer is no, because the denominator becomes 0, which the left side becomes undefined. So we are not going to consider negative 3. So we use hollow dots. Okay, now we are going to pick a point, okay, in our 3 regions. The first region, let's have all the numbers less than negative 8. Pick any number that is less than negative 8. So you can use negative 10, negative 100, as long as any number that you like. Okay, let's say x equals negative 9. Okay, so substitute negative 9 to our original inequality. So we have negative 9 minus 2 all over negative 9 plus 3 is less than 2. We have negative 9 minus 2 equals negative 11, and negative 9 plus 3 equals negative 7. negative 11 over negative 7 is actually 11 over 7. Is 11 over 7 less than 2? Yes, 11 over 7 is less than 2. In fact, if we are going to transform this fraction into decimal, we could have around 1.57. So 1.57 is less than 2. Therefore, that is true. And we're going to consider the numbers that is less than negative 8. So the interval notation of that is we have the open interval negative infinity to negative 8. Now, let's have the second region. So we have to pick any number that is between negative 8 and negative 3. Okay, so let's say negative 4. Okay, now we are going to substitute negative 4 to our inequality. So that becomes negative 4 minus 2 all over negative 4 plus 3 is less than 2. Now negative 4 minus 2 is negative 6 and negative 4 plus 3 equals negative 1. And negative 6 over negative 1 is actually 6. Can we say that 6 is less than 2? Of course, it's not. Therefore, it's false. Okay. Let's have the third region. We have to pick any number that is greater than negative 3. So, any number that you like as long as it's greater than negative 3. So, let's say 0. So, we substitute 0 to our inequality. So, 0 minus 2 all over 0 plus 3 is less than 2. 0 minus 2, of course, negative 2. 0 plus 3 equals 3. So, we have negative 2 over 3. And that is actually the negative of 2 over 3. Should we say negative 2 over 3 less than 0, less than 2? Yes, it's less than 2. Therefore, it's true. And we are going to consider the open interval negative 3 to positive infinity. Now, let's identify the values of x. And we are just going to consider all the intervals that are true. And since these are our interval, we use union. And that would be the values of our x. Let's have another example. Let's say find the values of x that will satisfy x squared plus 3x plus 2 all over x squared minus 16, which is greater than or equal to 0. First step, we have to simplify the given inequality. In this case, the inequality x squared plus 3x plus 2 all over x squared minus 16 is greater than or equal to 0. We have the numerator is a trinomial. We have to determine first whether the numerator can be expressed in a factored form. So x squared plus 3x plus 2. Are there any number that we have to multiply the 2? Okay. Are there any two numbers that the product is 2, but if we're going to add those numbers, the sum is 3? Yes, there is. Therefore, it can be factored. Now, the denominator, x squared minus 16. Is the denominator can be expressed in the factored form? Yes, it can be. So, the factor of x squared plus 3x plus 2 is actually the quantity x plus 1 times the quantity x plus 2. And the factor of the denominator x squared minus 16 can be expressed into the quantity x minus 4 times the quantity x plus 4, which is they are greater than or equal to 0. Now, we have to equate the numerator and denominator to 0. Now, take note that what we are going to consider is this form. Okay, So the numerator, x plus 1, this one, should be equal to 0. And of course, any number that is added by 1, the result is 0, that is negative 1. Then we have x plus 2, okay, equals 0. And the x here equals negative 2. Then we have x minus 4. Okay, so the x minus 4 equals 0, x is 4. Now, the last denominator rather, is x plus 4 equals 0. Now, what would be the number added by 4? The result is 0. That is negative 4. So, we have 4 key points or critical points to be used in our in solving or in finding the values of x. Okay, now we make a number line. So we have to plot the points. That would be for our negative 4, then our negative 2, negative 1, and 4. Remember that we have to plot the lines. Okay. So since we are going to plot the points rather, we have to make the points in chronological order. Okay. Now, in this case, we have the regions to be considered. We have less than negative 4, all the numbers that is less than negative 4, the numbers in between negative 4 and negative 2, the numbers in between negative 2, negative 1, the numbers in between negative 1 and negative 4, and the numbers greater than 4. Now, should we consider negative 4 in our testing of points? Now remember that if we are going to substitute negative 4 in our equation, the denominator becomes 0. So since the denominator becomes 0, this will become 0, then we are not going to consider negative 4 because it makes the fraction undefined. So in other words, we are going to use the hollow dot. Now, should we consider negative 2 in our testing of points? Now, if we're going to substitute negative 2 in our equation, the numerator becomes 0. And if the numerator is 0, the fraction becomes 0. Now, should we consider this one? 0 greater than or equal to 0? Yes, we are going to consider because the given inequality is greater than or equal to 0. Since we can consider equal to 0, then we are going to use solid point. Now, should we consider negative 1? If we are going to substitute negative 1 to the equation, to the given inequality rather, the numerator becomes 0. So we have 1 minus 3 plus 2. That is 0. And since 0 and the given inequality is greater than or equal to 0, since we are going to consider equal 0, then we are going to use solid point or solid dot. Now, should we consider positive 4? In this case, the denominator, if we are going to substitute 4 in our given inequality, the denominator becomes 0. Since the denominator becomes 0, that becomes undefined. Therefore, we're not going to consider 4. And we are going to use hollow dot. So in this case, we have 5 regions to consider. Okay, so pick up test point. So we have this region. So any number that is less than negative 4, let's say negative 5. You can use any numbers. You can use negative 10, negative 11, negative 6, any number. So let's say in this case we have negative 5. And then we are going to substitute the negative 5 to our inequality. Okay, so you have negative 5 squared plus 3 times negative 5 plus 2 all over negative 5 squared minus 16 is greater than or equal to 0. So you have this one. So you have negative 5 squared, negative 5 times 5, and negative 5 times negative 5 is positive 25. 3 times negative 5 is negative 15. Copy the 2. Negative 5 squared is 25 minus 16. So 25 minus 5, that's actually 10 plus 2, that's 12. Then 25 minus 16. So we have 12 all over 9 greater than or equal to 0. Is this true? Is negative 12 over 9 greater than or equal to 0? Yes, it's true. Therefore, we're going to consider the open interval negative 8, negative 4. Okay, another region. We have to pick any number between negative 4 and negative 2. Okay, let's say the number is negative 3. Substitute negative 3 to the given inequality. So you have negative 3 squared plus 3 times negative 3 plus 2 all over negative 3 squared minus 16 is greater than or equal to 0. So you have negative 3 squared is 9, negative 3 minus 3, that's negative 9, plus 2, negative 3 squared, that's 9, and 16, negative 16. So 9 minus 9, 0, plus 2 equals 2. 9 minus 16 is you have 7. So negative 7 rather. Is negative 2 over 7 greater than or equal to 0? No, it's false. So since it's false, because negative numbers are always less than 0, so that's false. Okay, negative 2 over 7 is greater than 0 or greater or equal to 0, that's false. Okay, so we're not going to consider this region. Another region. We have to pick any number that is greater than negative 2 but less than negative 1. So let's say we have negative 3 halves, that is negative 1.5. Okay, substitute, you have negative 3 over 2 squared plus 3 times negative 3 over 2 plus 2 all over negative 3 over 2 squared minus 16 greater than or equal to 0. Then we have, okay, so negative 3 over 2 squared, that's equal to 9 over 4. So 3 times 3, 9, 2 times 2 equals 4. Then we have 3 times negative 3, that's negative 9 over 2, that's 2. Then this is 9 over 4 minus 16. Now, since, as you can see here, in our numerator and denominator, they are not in similar terms. Okay, since we're going to operate fractions, so we're going to make this one a similar term. So we have to make all the denominators in the numerator becomes 4. So what number we're going to multiply 2 to make it 4? That is 2. What number that we're going to multiply by 1? We're going to multiply to 1 to make it 4. That's 4. So in other words, this must be multiplied by 2 and this is multiplied by 4. So you have 9 minus 18 plus 8. Then we have negative 1. So in other words, the whole numerator can be expressed as negative 1/4. Now, in the denominator, we should express 16 in which the denominator is 4. So we have to multiply 16 by 4. 16 times 4 is equal to 64. So 9 minus 64 equals 55, negative 55 over 4. So negative 1/4 divided by negative 55 over 4 is actually, okay, 1 over 55, which is greater than or equal to 0. So that is true. So in other words, we're going to consider this interval. So that interval, we have close interval negative 2, negative 1. Okay, we have this interval, this region. So pick any number between negative 1 and 4. So let's say 0. Substitute 0 to the given inequality. So you have 0 squared plus 3 times 0 plus 2 all over 0 squared minus 16 greater than or equal to 0. So you have 2 over negative 16 greater than or equal to 0. Should we say negative 1/8 greater than or equal to 0? Of course, it's false because the left side is negative and negative numbers are less than 0. Okay, the last region, pick a number, let's say 5, substitute the 5, and then 5 squared plus 3 times 5 plus 4, plus 2 rather, all over 5 squared minus 16, greater than or equal to 0. So we have 25 plus 15 plus 2, all over 25 minus 16, is that greater than or equal to 0? So you have 25 plus 15 plus 2, that's 42, and 25 minus 16 equals 9. Is 42 over 9 greater than or equal to 0? Yes, it's true. So we have to consider the open interval 4 to positive infinity. Now, to make the values of x, we're just going to consider all the true regions. So, since we have 3 intervals, we put it union, then we have the union of the open interval negative infinity to negative 4, closed interval negative 2, negative 1, and open interval union 2, close interval, open interval 4 to infinity. Now, if you're going to notice all the examples that we have something like pattern: true, false, true, false, true. It's not always the case that the patterns true, false, true, false, true, or false, true, false, true, false, true. Okay, it's not always the case. There are times that we have true, true, false, or false, true, true, or false, true, true, false. Something like that. So, baka sabihin nyo na, ay, pattern lang, ang dali-dali. Hindi. We have to test really the points to determine whether the given region is true or not. So, that's it for today. Thank you.